let's revisit our population model for mice that we saw in our last example. In that example, the population of mice, P of t, in a field t months after initial measurements are taken can be modeled by dp dt equals p over 2 minus 450. We found the solution to be given by p equals 900 plus k times e to the t over 2. But what if we wanted to use our model to predict the number of mice after 1 year? In terms of our variables, this is asking what is p at 12 months after the initial measurement was taken. Now, because of the unknown constant k, we are unable to make a prediction. This is because our model is based on the rate of change dp dt. And similar to what we learned in integral calculus, we can only predict the change in our function from the rate of change. So to fully find p of t, we need some information about p of t. It is sufficient to know just one data point, p at t naught equals p naught. Such a data point about p of t is called an initial condition. Suppose that the initial population at time t equals 0 is given by the initial condition p of 0 equals 905. Now let's find the model's prediction for the number of mice in the field after 1 year. Using our initial condition, with the family of solutions p of t equals 900 plus k times e to the t over 2, we can determine the value of k. In particular, we have that p of 0 is 905 from the initial condition, and from our model, we have that p of 0 is 900 plus k times e to the 0 over 2. And since e to the 0 is 1, the right-hand side simplifies to 900 plus k, which we can easily solve by subtracting 900 from both sides to get that k equals 5. And this leaves us with the solution p of t equals 900 plus 5 times e to the t over 2, replacing k equals 5 in our earlier family of solutions. And now that we know p of t, we can evaluate this at t equals 12 to find that p of 12 equals 900 plus 5 times e to the 12 over 2, which is roughly 2,917. So this model predicts that after 1 year, the population will grow to 2,917 mice. If this seems like it's a bit high, it's because our model gives an exponential function for p of t. It doesn't consider that there's a maximum sustainable population. I want to note that later in the course, we will improve on this model to add a maximum sustainable population, rather than the unbounded growth given by this exponential function.